Venus. The name itself evokes beauty, the goddess of love in Roman mythology. This celestial body, our closest planetary neighbor, shines brightly in our night sky, a beacon of brilliance. For centuries, mankind has gazed upon Venus with wonder, its mysteries beckoning us. What secrets lie hidden beneath its thick, swirling clouds? What stories could this planet tell if only we could listen? Venus, the fiery twin of Earth, holds the key to unlocking many secrets of our solar system. As our nearest planetary neighbor, Venus has always captivated our imaginations. Its brilliant presence in the night sky, sometimes as the morning star, sometimes as the evening star, has earned it a special place in our mythology and folklore. But beneath this alluring beauty lies a harsh reality, one that challenges our understanding of planetary evolution and the very limits of life as we know it. Despite its hostile environment, Venus holds a certain allure for us explorers. It is a planet of stark contrasts, a place where beauty and danger coexist. Its thick atmosphere, shrouded in perpetual clouds, hides a landscape sculpted by volcanic activity and extreme temperatures. Yet, even in this unforgiving environment, some scientists believe that Venus may hold clues to the origins of life itself, perhaps even harboring some form of extremophile life in its upper atmosphere, where conditions are slightly less extreme. The allure of Venus lies not just in its mysteries but also in its potential. Some visionaries see Venus as a future home for humanity, a place where we might one day build floating cities and terraform the planet to suit our needs. While these ideas may seem like science fiction today, the human spirit of exploration knows no bounds. And so we continue to study Venus, to unravel its secrets, and to dream of the day when we might walk upon its surface. Venus and Earth, born from the same cosmic cloud of gas and dust billions of years ago, emerged as planetary siblings. The early solar system, a chaotic swirl of matter, gradually coalesced under the pull of gravity. Within this swirling disk, dust grains clumped together, forming larger and larger bodies. These planetesimals, the building blocks of planets, continued to collide and accrete, eventually forming the planets we know today. Venus and Earth, forming in roughly the same region of the solar system, likely started with similar compositions. Both planets, rocky worlds with similar sizes and masses, held the promise of becoming habitable worlds. Early Venus, scientists speculate, may have even had oceans of liquid water, a key ingredient for life as we know it. But fate, it seems, had other plans for these planetary twins. As the young sun slowly brightened over eons, its increasing energy output had a profound impact on the inner planets. Venus, closer to the sun than Earth, felt the brunt of this increased solar radiation. The once temperate climate of Venus began to change, setting in motion a series of events that would dramatically alter its destiny. This is where the paths of the two planets diverged. While Earth evolved into a haven for life, Venus embarked on a different journey, transforming into the scorching, inhospitable world we know today. The story of Venus serves as a stark reminder of the delicate balance that governs planetary habitability. It highlights the profound impact that seemingly small changes, like the distance from a star or the composition of an atmosphere, can have on a planet's fate, and it underscores the importance of studying our planetary neighbors, for in their stories we may find clues to our own past and future. Venus, once potentially harboring oceans, fell victim to a phenomenon known as the runaway greenhouse effect. This process, driven by the sun's relentless energy, transformed Venus from a temperate world to a scorching inferno. Understanding this process is not just about unraveling the past of Venus, but also about comprehending the delicate balance of our own planet's climate. Sunlight, as we know, carries energy. When sunlight reaches a planet's surface, some of it is absorbed, warming the planet. This heat is then radiated back into space as infrared radiation. However, certain gases in the atmosphere, called greenhouse gases, can trap some of this outgoing radiation, preventing it from escaping into space. This trapping of heat is what keeps planets warm enough to support life, like a blanket around the planet. On Earth, the greenhouse effect is a natural and necessary process, maintaining our planet's temperature within a range suitable for life. However, on Venus, this process went into overdrive. As the sun's energy relentlessly bombarded the planet, it caused water on the surface to evaporate, releasing water vapor into the atmosphere. Water vapor itself is a potent greenhouse gas, trapping even more heat. This led to a vicious cycle: more heat, more evaporation, more water vapor, and even more trapped heat. The temperatures on Venus continued to soar, eventually reaching levels capable of melting lead. This runaway greenhouse effect transformed Venus into the hellish world it is today, a stark warning of what can happen when the delicate balance of a planet's climate is disrupted. Imagine a world shrouded in perpetual twilight, the surface obscured by thick yellowish clouds. This is Venus, a planet of extreme contrasts, where searing heat and crushing pressure create a landscape both beautiful and terrifying. The atmosphere, a dense cocktail of carbon dioxide and nitrogen, traps heat with ferocious efficiency, resulting in average surface temperatures exceeding 460 degrees Celsius, hotter than a pizza oven. The Venusian landscape, sculpted by intense volcanic activity, is a testament to the planet's inner turmoil. Vast plains of volcanic rock stretch across the surface, punctuated by towering shield volcanoes and colossal impact craters. Lava flows, some extending for hundreds of kilometers, scar the land like ancient wounds, a testament to the planet's violent past. But the true terror of Venus lies in its atmosphere. The air, heavy and toxic, is a swirling concoction of carbon dioxide and sulfuric acid. These thick clouds, while reflecting sunlight and giving Venus its high albedo, also trap heat, creating a runaway greenhouse effect that has turned the planet into a furnace. The atmospheric pressure at the surface is a crushing 90 times that of Earth, equivalent to being a kilometer beneath the ocean's surface. Standing on the surface of Venus would be an experience unlike anything on Earth. The air, thick and hot, would make every breath a struggle. The pressure, immense and unforgiving, would threaten to crush you, and the heat, relentless and all-encompassing, would melt any known material. Yet this hellish world, with its extreme conditions and alien beauty, continues to fascinate us, beckoning us to unravel its secrets.